I did it again. I just forgot approaches to problem solving. I forgot the title of chapter 2 again, and I had it in my head, and I had it. Then I hit record, and it went poof. All right. So in the last section of approaches to problem solving, we're looking at Unit 2C, problem solving hints. Now, these are the most important guidelines and hints that any math class has ever told you. I'm kind of blown away by this section. I really like it. First of all, there may be more than one answer. And this is almost always true in life, right? We're not talking about solving math problems. You're not going to find some math book on the street and start doing problems at the bus stop one day because it's so much fun, right? This is problem solving for the real world. Always keep in mind there may be more than one answer. There also may be more than one method. Use appropriate tools for the situation. Sometimes you need to pull out a calculator, and sometimes you could just approximate, like we talked about with the Fahrenheit and Celsius. Sometimes we should consider similar problems. Consider equivalent problems with easier solutions. Like, okay, well, if this were held constant, what would happen? And you can kind of get an idea of what the problem is. Approximation's always useful. Try alternative patterns of thought. Now that's super easy to say, but I think like I think, and it's hard to change up how I think because I've been thinking like this forever. And you're probably the same way, but give it a shot. Listen to how someone else solves a problem and see if that helps you at all. Most importantly, don't spin your wheels, right? Don't just stay in the same problem being stuck. Try something, anything. If it doesn't work out, well, that's one way that doesn't work. So you're you're on your path to finding something that does. Always try something. All right, let's look at box office receipts. Tickets for a fundraising event were priced at $10 for children and $20 for adults. I would have priced it the other way around, but that's just me. Shauna worked the first shift at the box office, selling a total of $130 worth of tickets. However, she did not keep a careful count of how many tickets she sold for children and adults. How many tickets of each type, child or adult, did she sell? Well, we don't really know, and the first thing that occurs to me is set up a system of equations, but that's because I'm a math professor. I don't know, what happens, why not just try something? Suppose Shauna sold one child ticket. One for $10, so $130 minus $10 is $120 worth of adult tickets, and the adult tickets are $20 a piece, so that's 6 adult tickets. So we found an answer. She could have collected $130 by selling one child and 6 adult tickets, but it's not the only answer, right? Suppose she sold 3 $10 child tickets for a total of $30. Then she could have sold 5 of the $20 adult tickets. In fact, there's more possibilities. Maybe 5 child tickets and 4 adult, 7 child, 3 adult, 9 child, 2 adult, 11 child, 1 adult. She could have just sold children's tickets and there's not an adult in there. Without further information, we don't know which combination represents the actual ticket sales unless we were to go in and count. Just saying. But there are plenty of other answers that are also correct. Which one's the most correct? We don't have enough information for that. So if you find an answer, don't always assume it's the only answer. Jill and Jack ran a 100-meter race. Jill won by 5 meters. That is, Jack had only run 95 meters when Jill crossed the finish line. They decided to race again, but this time Jill starts 5 meters behind the starting line. Assuming that both runners run at the same pace as before, who will win? It's nice of them to tell us that in the future slides we'll see the solution, even though they tell us up here too. Thank you, Pearson. All right, so here's method 1. We could math this up, right? Let's analyze each race quantitatively, so with numbers. We know that Jill ran 100 meters in 20 seconds, which is 5 meters per second. Jack did not run the full 100 meters in those 20 seconds. He only ran 95 meters in the same 20 seconds. So his pace is 4.75 meters per second, right, over the course of this race. For the second race, Jill has to run 105 meters. But if we divide that by 5 meters per second, or instead of dividing, we multiply by the reciprocal, so we switch this over. 5 meters over 1 second now becomes 1 second over 5 meters. 105 divided by 5, it takes 21 seconds for Jill to run 105 meters. And what about Jack? 100 meters divided by 4.75 meters per second, right? He's running the shorter race in this case. Instead of dividing by 4.75 meters divided by 1 second, we're going to switch to multiplication and multiply by the reciprocal of that fraction, which is 21.05 seconds. So Jill crosses the line still a little bit ahead of Jack, like by just the tip of her toes. Great answer. Jill still wins. And that works, all right? But in the first race, Jill runs 100 meters in the same time that Jack runs 95 meters. But if we have our 100-meter race here, here's our 0, here's our 100, but Jill is over here at -5. Jill ran all the way up to this 95 line, which is actually 100 meters for her, in 20 seconds. At that same 20 seconds, Jack has just hit the 95-meter mark as well. So at 20 seconds, Jack and Jill are both at the 95-meter mark, but Jill had a longer distance to run. She's been able to catch up. Why is she catching up? Because she runs away a little faster, and since she's a little faster, she'll still cross the line before Jack. Notice how we didn't need to really math it. We don't have to use a calculator. We use reasoning skills, and it's the same answer. Jill is still going to win. How much does she win by? We don't know on either one of them, really. We could find it with the quantitative, but we weren't asked to. Many different ways of going about solving the same problem. And that's it. Just keep in mind that an answer is not always the answer. Right? There could be multiple answers, especially in life. And you don't always have to solve something with math in order to solve it logically, right? You've been through the critical thinking. Now we've talked about units and conversions and problem solving. These aren't just for solving math problems. They're really for solving your life problems. I'm going to see if I could use some of them. Thanks for listening. Let me know if you have questions on the homework.